All right, homework 9, which has some inflation questions, that's due on Thursday by, no, not 1 o'clock. You've got until 4 o'clock, right? That's how we do it. 4 o'clock on the 13th. And then the project is due by 4 o'clock on Thursday the 20th. So before we continue talking about inflation and the learning curve, are there any questions related to the homework or the project that you'd like to ask right now? No? Okay. Here is a graph that's provided by the St. Louis Federal Reserve Bank. I guess the Federal Reserve has different regional branches, and maybe the different branches are assigned to track different things. And so the St. Louis Federal Reserve Bank has this graph that shows the unemployment rate in the United States. And what the Federal Reserve Bank in the U.S. is trying to do is balance unemployment and inflation. And as we'll see in the coming couple of slides, there's a delicate relationship between unemployment and inflation, because when there is, I guess how to put this, if too many people have jobs, then prices are going to be going up more than they ought to. And the reason for that is that there's maybe a certain fraction of people who will be either unqualified to work, or maybe between positions, or maybe not very enthusiastic about work. And so to entice those people, to entice someone to work who doesn't actually want to be working, you have to give them a really favorable and lucrative job offer. Or, you know, if you're putting people in positions who aren't really qualified, then you're also going to have some problems there. But typically, I think in the United States, the range of full employment, you know, there's this phrase, full employment. It's not 100% people employed. Full employment is usually about an unemployment rate of 5% or less. If it's in the 5% or less range, people are pretty comfortable with that. But to get more people employed and to have the unemployment rate below 5%, you're really having to pay a lot, so that it kind of floods the economy with more money than would typically be in the economy, and it can drive up prices. And that's kind of what we're going to see in this figure. This is showing the unemployment rate from 2000. I know it's probably hard to see because the numbers are so small, but at the far left end here is 2000, and then here is unemployment up to and including the present. And so what you see is that there was a rise in unemployment that's associated here in shaded. It says here shaded areas indicate U.S. recessions. And so that's the periods of recession is when the gross domestic product is contracting, when the economy isn't growing. And so when the economy isn't growing, companies don't need as much labor, and it can drive up the the unemployment rate. And so the economy did poorly, companies laid off their employees, and the unemployment rate was above 5%. And so if you think about the area above the curve, you can think of that as kind of like pain. Anytime you've got more than 5% unemployment and it extends for several years, like this is a period of probably, more than 4 years. This is like people who are suffering, falling behind on their mortgage. They're not saving for retirement like they ought to. And so this was a period of pain that maybe followed the first dot-com bust. And then there was a bigger period of recession when the housing market went through a bubble and the bubble popped. And so there's lots of pain here, lots of economic pain. And for many years in a row, the unemployment rate was decreasing, but it took basically, 7 years to get back down below 5%. And now the unemployment rate was getting even lower, and a lot of people started to worry about inflation when the unemployment rate was below 5% because they were thinking that there's more wages going out into the economy, and more wages are going to drive up demand because people have more money than they ordinarily would. And if the demand is going up, the only way to allocate the demand for scarce resources is by increasing prices and finding out who really wants it for the newer, higher price. And of course, we know that there was this anomaly that took the unemployment rate up to nearly 15% in the United States due to COVID, but it came back down relatively quickly. And in fact, it went back down even as low as it's ever been to these historically low levels. So price stability is defined as inflation averaging 2%, but what we see is that after the pandemic, the price was anything but stable. Like the Federal Reserve would prefer that it just hover kind of in the 1 to 3% range, but averaging 2. And I mean, this does seem to, hover around the 2% range for a lot of it. But the problem was recently when inflation went up to above 8%, and a lot of people are feeling the pain of it. Now, what about when it's below 0%? That's pretty uncommon, but it has some serious side effects. We'll talk in a minute about what's the mindset that people go through when there are periods of deflation. But think about what's the mindset if you live in an economy where there's lots of inflation. What's your incentive to do with your money? If there's lots of inflation, what that means is that prices are going up. So we don't know necessarily what the interest rate is, but have you ever seen the pictures of what happened in Germany in the 1930s? Wheelbarrows full of money? You haven't seen those pictures before? Let me, since so many people say no, let me just see if I can do a quick Google image search. And I'll say hyperinflation Germany. So people would get stacks of money, and you'd have to have like this much money for a loaf of bread or something. It was just kind of, the money had so little value that kids would stack it up as toys. So when prices are going up really, really fast, your incentive is to spend it as quickly as possible. If you get paid in the morning and you could buy 5 loaves of bread, but then if you wait until the evening you can only buy 3 loaves of bread, then you're going to spend the money as soon as you get it in a hyperinflation environment. But the reverse of that, deflation, gives you a different incentive. And we'll talk about that incentive. Now this is where I've lined up the two trends on top of each other. So the top is unemployment, and the figure beneath is inflation. And so what you see, for example, in the COVID era is that there was a big period of unemployment, and briefly that dropped the inflation down below 2%. But then in order to get people back to work, a lot of companies post-COVID started jacking up the rates that they pay to people. So that was, the era of, number one, a lot of, what did they call that? Economic stimulus payments. Remember when they were giving each person $1,200 or something? Did anybody here get those stimulus payments? Mm-hmm. Yeah, I got it. You didn't get one, Ben?
No.
Okay. I guess maybe you hadn't graduated soon enough or something.
No, my stepdad makes too much money.
Gotcha. Well, the economic stimulus payments combined with the rising wages drove down unemployment really quickly, but it also caused this abnormally high inflation. So there's another figure. So besides the relationship between employment and inflation, which I hope you'll be able to explain, like if there's a concept question on an exam, the fact that, you know, typical unemployment of 5% is associated with typical price stability of 2% increase in prices each year. But if inflation, if unemployment goes below 5%, the way that you get those people incentivized to work is by increasing wages, which increases inflation. So I hope you'll remember that trend. Another way that the Federal Reserve can monitor and influence inflation is by the rates that they charge to banks. There are a lot of banks that have to sometimes go to the Federal Reserve to borrow money on a short-term basis. And so when the Federal Reserve Bank increases the rate that they charge to commercial banks, then people expect that is going to be associated with increased inflation. So what we see is in like the post-COVID era, on the left side, this is corresponding to the orange line. So it's the rate, the federal funds rate expectations. And so this is what people expect the interest rate is going to be that the Federal Reserve Bank charges to other banks, to commercial banks. And what they saw was that they expected the Federal Reserve is going to start increasing the rate that they charge. And that's panned out to be true. You know, the mortgage interest rates have been going up, auto loan interest rates have been going up, and those have been driven up because the Federal Reserve Bank has increased the rate that they charge to commercial banks. But what gets driven up at the same time is people, consumers, begin to expect that inflation is going to exceed 3%. And so this vertical axis on the right side is saying it's the probability that inflation will exceed 3%. And that's in kind of the uncomfortable zone. Like if it varies from 1 to 3%, people are okay with it. But the expectation has been that inflation would be above 3%. People have been putting the probability of that in the mid 30%. And of course, it definitely did. When we see that the actual inflation went as high as 9% for a period, that actually did come true, that increasing the federal funds rate also contributed to inflation. So it's partly about how many people are working and the income that they receive that drives up inflation, but it's also related to the interest rate that is charged by the Federal Reserve. All right, now let's talk about deflation, which doesn't happen very often because it's so dangerous. Central banks do everything they can to avoid the deflation. So it's sometimes called a deflationary spiral, and the spiral is kicked off by the recognition that if prices are going down, people should hold on to their money because you can buy more in the future for less. So remember, it's the opposite of inflation, which is with inflation you want to spend your money quickly because it's not going to be worth as much in the future because prices are going up. But if the price of food will be cheaper in the afternoon than it was in the morning, then you're going to put off your shopping to the afternoon. Or if you think that cars next year are going to be less expensive than cars today, then you'll put off your purchase to the future. And that makes sense for the individual, but it's dangerous for the economy. And here's the reason why. Let's say demand is going down, and what could kick off the deflationary spiral? There's a variety of things. It could be that people are worried about losing their job, and so they're so-called belt tightening. You know, they're cutting back their expenses, the kind of discretionary expenses, and so they're trying to spend less money. So it might be just worry or precaution that is causing people to buy less items, or it could be that they're actually unemployed and they simply don't have as much money, or it could just be the impression that things will be cheaper in the future. Any of those could cause a fall in demand. And so if demand for products decreases, remember that what we've talked about is the relationship between demand and prices is that if you want to drive demand back up, the only lever that you have to pull on as a producer is by decreasing the prices. So why would a producer decrease their prices? Well, because that's what will increase the demand again. So they're trying to increase the demand by reducing the prices, and what happens next is debt defaults. So why would it be the case that decreasing prices could lead some companies to default on their loans?
Less revenue?
Because they're getting less revenue, right? And it could push them past that optimal point. I mean, you have to understand that if they already were operating at or near their optimal point, which is maximizing the profit, as inventory accumulates and they have to get rid of it, they're pushing past it. So they're going further to the right of the optimal demand by decreasing their prices to try and sell more units. And so they have less revenue coming in. They're more likely to default on their loans. And then that means if they can't pay their creditors, they're bankrupt, which means that their firm may dissolve, and it may stop operations completely. There's other kinds of bankruptcies where the firm remains in operation, but just they maybe go through cost cutting, or they lay certain people off, or some of their creditors only get a portion of the money that they're owed. And so that's leading to layoffs. Is if the company has become bankrupt and they are looking for emergency ways to cut costs, they may let some of the employees go who are maybe less productive, or the product lines that they have, which are their least profitable product lines, they could let go and try and just trim down. And so now you've got more people who are in the belt tightening mode, and their budgets are contracting, and so then that contributes to even more falling demand. So the people who've just been laid off are going to buy less, and then we go through this whole cycle again. The people who've just been laid off buy less, and so the prices have to fall further because there's less demand than there was before, which means that more companies are teetering closer to debt defaults. And so this deflationary spiral kind of feeds into itself. And it's very tricky and difficult to get out of a deflationary spiral. And so that's why if you look at how rarely it happens, they'll do just about anything to avoid getting below 0%. And I mean, I guess it's not that difficult to get out of it. All the government really has to do is print more money. And so if they print more money, then that's going to cause an inflation in prices. But it's kind of an unfair way to get out of deflation, because it doesn't necessarily help the firms that are threatened due to bankruptcy. It's just devaluing the currency. So that's the deflationary spiral, and that's another thing that I hope that you'll be able to explain kind of in conceptual terms is, you know, why these different things are related to each other and how a chain of events could cause reinforced falling demand. This is a graph of savings rates over time, and through the 80s it was far more common to have certificates of deposits and savings accounts that had pretty generous payouts, and I ought to get an updated savings account graph because I think they're finally coming back up again. But over time they've been pretty low because the federal funds rate has been relatively low. But I just wanted to talk a little bit more. I introduced this formula in class last Thursday, but I wanted to talk about it a bit further and help define the difference between the real interest rate and the inflation adjusted interest rate. And so this I sub F is what the bank actually pays when you deposit money to your account. Now, the bank isn't making any promises about what the real rate of return is, and they don't necessarily know or tell you what is the inflation rate. They tell you how much interest they're going to pay on a percentage basis, and that's this I sub F. And if you know the inflation rate, F, then you can calculate the real interest rate, I. And from our in-class exercise on Thursday last week, what we found on the last problem was that you'll have a negative real interest rate if inflation is greater than the market interest rate. So remember the phrase purchasing power, and purchasing power decreases if you have a negative real interest rate. So anytime the inflation rate F is larger than the market interest rate, then that means you have a negative real interest rate and your purchasing power is decreasing over time. So these are some graphs that show the real interest rate, which is this I, which we really care about, is purchasing power. If you want to be able to buy more things in the future than you can buy now, then you want to have a positive real interest rate. And so this is showing that we've been through a long, extended negative real interest rate since about 2010 and continuing to the present. Even though interest rates are higher now than they have been before, it's still not positive real interest rate because inflation is so high. So the banks pay the market interest rate, and during an environment of high inflation, you could have a negative real interest rate. So the market interest rate maybe is more than inflation F, and if that's the case, your real interest rate is positive and your purchasing power goes up over time. But if the market interest rate is less than the inflation rate, then your purchasing power decreases. So part of the reason why banks will never quote a real interest rate is it's difficult to calculate, and it can vary on a day-to-day basis. Inflation can be changing, and there's a lot of disagreeing definitions on what prices to include in inflation. Because, for example, some consumers who commute a long distance every day, maybe they're more sensitive to the changing price of gasoline. Where if somebody is walking to work, then they could be completely insensitive to the price of gasoline, at least directly. They'd only care about how the price of gasoline affects other things like maybe food or clothing or entertainment prices. So for one reason that banks don't quote the real interest rate is just F is so difficult to quantify. But then the other is that it's not to their benefit for people to know that saving money, you're actually losing purchasing power. Fewer people would make deposits at banks if they realized that you are losing money over time. And unfortunately, I have money in the bank that's losing value because prices are going up more quickly than I'm earning interest. And so it's just the only reason I keep money in the bank is my pessimism about the stock market. I just kind of think the stock market could maybe even do worse than the bank. Of course, over the long term it won't, but in the short term it certainly can. If you are trying to account for inflation when you're calculating future amounts, there's two different ways that we can account for inflation. And the first is you could calculate the cash flows that you know into constant value dollars and then use the real interest rate in calculating future amounts. So what that means is if you know, for example, that you are going to be earning revenue on some project in the future, then what you could do is you could discount that future revenue to the present at the inflation rate, F, and then you would use the real interest rate in calculating future amounts that you'd need to have to justify it. So like if you're trying to achieve a certain rate of return in your project, then you'd use both the inflation rate and the real interest rate depending on whether it's an inflow and an outflow. The other approach to this is that you use the cash flow, leave the cash flows as they are, like meaning the amount that they'll actually be paid out in the future rather than trying to find the present value equivalent of that. And then you use the market interest rate in calculating the future amounts. So let me show you an example of that if we're trying to take into account capital recovery. So remember that capital recovery is the annualized cost of ownership when two factors are taken into account, the initial purchase price and the ultimate salvage or disposal value of the equipment. So we want to find out with capital recovery, how much should we be making each year just to cover the cost of owning the equipment without any kind of maintenance costs factored in, just the cost of purchasing the equipment on an annualized basis. So we can perform capital recovery calculations with the market interest rate, I sub f, because if in the formula to find A given P, so this is the formula for find A given P, if we calculate the market interest rate that would correspond to a desired real interest rate, I, so that's how much you want your purchasing power to increase, and the expected inflation rate, F. So you'd find out, if you know how much you have to pay for the equipment today, and you know what it's going to sell for in the future, and you want to know what is your real rate of return that you're going to earn, then the two-step problem would be first, calculate the I sub f, and then substitute I sub f into this formula. All right, so let's practice that with this first problem. All right. So in this problem, we're going to buy a crane for $550,000. And the capital recovery is going to be relatively simple here because we're assuming it has no salvage value in 5 years. But we want to know, how much does the company have to recover each year if we want a real rate of return of 9%? And so real rate of return means I equals 0.09, and the inflation rate of 5.5% means F is 0.055. So the first thing we need to do is calculate I sub F. So let me bring that formula back up. So I sub F is I plus F plus I times F. So once we calculate I sub F, then we're going to put it into the equation here to find A, where P is the present cost of $550,000. So P is $550,000. How much revenue would we have to receive to justify that equipment? Okay, so our inflation-adjusted interest rate is 0.14995. And then to find A, which is the annual amount that we should be having as income to justify the equipment, it's our initial price of $550,000 multiplied by 0.14995 times 1.14995 to the power of 5 divided by 1.14995 to the power of 5 minus 1. So, did anybody calculate that? What'd you get?
I got 164,000.
Good. Yep, that's what I got as well. 164,054. So 164,054.13 if we carry it through to the nearest penny. So we're just accounting for two interest rates simultaneously there. Well, I guess one interest rate and one inflation rate. We're combining them together, and what we're saying is, I sub f till now, I've described this as the interest rate that the bank actually pays, but this problem isn't about a bank. This problem is about you, your company, and the rate of return you want to make on a project. And so simply, if you know the increase in purchasing power that you want to achieve, I, and you know what is the inflation, so the money that you're earning in the future isn't going to be as valuable as the money today that you're purchasing the item with. And so taking those both into account, the rate that you want to have an increase in your purchasing power and the rate that your money is becoming less valuable, then that tells you how much revenue should be earned to achieve your goals. Okay, so any questions about that example before we move on? All right. Well, the other thing that we're going to talk about today is learning curves, and this comes from cost estimation. And I think you've probably done some cost estimation in other classes. I think, if I'm not mistaken, that you've done like the unit technique in some of your other classes. And what this analysis will allow you to do is take into account increases in productivity that comes from an increase in skill. And so here is a picture of people working in a sewing shop where they become very, very skilled at sewing clothes. And so let's just say that we're going to work an example that's related to sewing shirts. And if the average worker were to go into that factory and sew their first shirt, maybe it could take them 12 minutes. So in the formula we're going to look at, which is a model for describing the rate of improvement in productivity, one of the terms that's in that model is you have to know how long it took them to do the thing the first time. And so we define that as K. That's the variable K. Now, this also applies not just to people, but productivity can be improved through automation as well. And here's kind of an interesting video that shows how automation is being used in a model that we can use to calculate how long it's going to take to do a certain thing when people are improving, when they're getting better at it. And so K, remember K was how long it takes to do the first time. Now we're going to define S as the ratio of how much time it takes to double your productivity. So by double your productivity, what it means is, like, if you went from having experienced the thing 10 times after having before that done it 5 times, if you measure how long it takes to do the 10th time 37 seconds and the 5th time 40 seconds, so you've doubled your experience going from 5 to 10. What's the ratio in time once you've doubled your experience? So doubling your experience could be like the 2nd time to the 4th, the 4th to the 8th, from your 100th time to your 200th time. So you're always looking for little ways to get faster. So like the first time you change your oil on your car, probably it's a really slow process. You don't exactly know where the drain plug is, or you maybe haven't figured out how you're going to snake yourself under the vehicle. But by the time you've done it your 2nd time, you're a little bit faster, and so on. So this S is just a ratio that's describing the reduction in input required when you've doubled your experience. So this learning curve is saying that you'll have a steep decline in the time required up front, but then it gradually starts to taper off, where you find the low-hanging fruit and you do all the easy improvements. This manufacturing progress function, or sometimes the experience curve as it's called, is just a way to explain increased productivity and estimate the effect of that. So here's the formula that we use to predict how long it would take to produce the a certain number. Like if U is the unit that we're trying to predict, maybe like the 10th unit or the 20th unit, then that is the U that we'd use here. And K, remember, was the first one that you made. And then you'll calculate some exponential factor n, which is the ratio of the log of S. And remember, S was this ratio where you're doubling the experience. And so log of S divided by log of 2 gives you n. And this formula we can use to calculate how long it would take to do something. And so let me show you, like in a real world application, how we'd use this formula. So let's say if it took you 85 minutes to sew a pair of pants the first time, then what that means is that K is 85 minutes. So let me write this on the board. For this example, K is 85 minutes. And then what we know is that the first pair of pants was 85, the second pair was 76, and the fourth pair was 68. So double productivity, going from the first to the second or from the second to the fourth. Let's check the S for both of them. So the S, when we're going from the first to the second, is 76.5 minutes versus the original of 85 minutes. So our S ratio there is 0.90. Okay, what is the S ratio when we go from the second to the fourth? Well, that ratio is 68.85 minutes versus the 76.5 minutes. So again, it was 0.90. Now, this is because this is an example I just made. In the real world, it wouldn't be perfect like that. You know, people don't follow like a perfect curve. It could be that maybe from the first to the second, it took maybe 0.85. The second to the fourth, maybe it could be 0.92. And so if you had multiple data points, then what you should do is calculate like an average S from several different increments. But in this case, we're just assuming it follows this perfect behavior. So S is 0.9. All right, so now N is going to be the log of S, which is the log of 0.9 divided by the log of 2. Okay, so if you've got your calculator handy, can you calculate what is the log of 0.9 divided by the log of 2? Do you get negative 0.1520?
Yeah.
Okay, so that is N. So we've got N and K. Now this is asking, how long will it take to sew your 10th pair of pants? So that means U is 10. So if U is 10, then how long does it take to sew the 10th pair of pants? So Z sub 10 will be K times U to the N. So that is, our K was 85 minutes. U is 10, because we want to know the 10th pair of pants, to the power of negative 0.1520. Okay, so this term is 0.70469. So if you multiply that by 85, then that means the 10th pair of pants is going to be 59.9 minutes. So the first time you did it took you 85, then the second 76.5. Basically, this is just showing how much better you get over time. And we could try applying this with Excel just to kind of automate the process. By the way, here's the calculations. For the 10th pair of pants is 59.9 minutes. But what about all of the pants, the first through the 10th? If we wanted to find the cumulative time that it took to sew all 10 pair of pants, that's where maybe Excel would make things a little bit easier, because then we could just calculate for different U's what is the... Go ahead.
If we have to solve that manually, then we have to calculate like for everyone, like S1 to S2, S2 to S3, S3.
No, we're given only the initial given data was from first to second and second to fourth. So this is the given data. Everything else we're going to be extrapolating based on that trend. So we only have to calculate S one time. So it'll be the same S for all of them. So let's say that we're using this formula that's on the screen here, and we'll have a pair, like we're going to do the first pair, the second pair, and so on. So the first, the second, the third, all the way down through the 10th pair of pants. And then the time that it takes. And this is all going to be based on S and N. And we already calculated the S was 0.9 and N was negative 0.152. Okay, so this was given the 85, and what else was given? 76.5, and the fourth we knew was 68.85. This was all a part of the given times, and it was from those given times that we calculated S and N. Okay, so for the third pair of pants, for example, we're going to do K, which is this initial value, times U, which is the pair number that we're on, to the power of N. And I'll anchor that reference so that it's always looking there. And does it kind of fit the trend? Like, it wouldn't fit the trend if it was bigger than 76 or lower than 68. But it's in between them. So we think it probably is following the trend. I could drag this down to the next one, and it should continue to say 68.85. If you drag it down and it says 68.85, it's the same. Drag it down through all of them. We can see that we're reaching some kind of minimum point where we made big gains in productivity at first, but the improvements are getting more modest. The more experience you have, the less opportunity there is for improvement, because you're approaching not necessarily perfection, but just kind of full awareness of all of the opportunities for improvement. So the total for all 10 pairs of pants would be 679.53, and this was units of minutes. So that's how long it would take to sew all 10 pairs of pants here, following this manufacturing progress function. Okay, so if you flip to the back side of the in-class exercise, we're going to apply this to what if you were thinking about a Rubik's Cube. And we have certain data, but we don't have all of the data. You're going to have to back calculate K, which you do have the data to do that. So you've got enough information here to find out what is S and to find out what is K. K meaning, of course, the first time you did it, you didn't measure it, but you can extrapolate backwards and estimate how long it took the first time around. And so we want to know for the 100th time, when u is 100, what will be the amount of time it takes to solve the Rubik's Cube? So for example, if from the second to the fourth, that 0.91 was 21.84 divided by 24 minutes. So this was the longer time, and that was the shorter time. So you could also say that 0.91 is the ratio of 24 divided by try number 1. So you're going to find out how long it took for try number 1, which we call that K.
Was U 100?
Yes.
Z is 8, right? Like, what's the number of input for each?
Oh, well, how long it takes? When you calculate, like you're asking for the final answer?
Well, no, it says, so U, the output unit number is 100.
Yeah, we want to know how long does it take for the 100th time you do the Rubik's Cube?
Is it 13.34?
No. Did you get this S value of 0.91?
Mm-hmm.
Okay. Once you get the S value of 0.91, then N for this one is going to be the log of 0.91 divided by the log of 2. So that should be negative 0.1361.
Yeah, I got that.
Okay.
What is
So
it?
what about K? What did you get for K?
26.37.
I also got
26.38 minutes. So it's got to take longer than 24, right? Because that was the second time you did it. So you're always getting better each time. So we know it has to be at least more than 24. So this ratio here of 0.91 tells us every time you double your experience, you're going to be only taking 91% time, 91% as much time as when you had half as much experience. So we find out that K is 26.38 minutes.
So I got a question.
Okay.
So how come when you're going from like 2 to 4, the ratio is 0.91?
Uh-huh.
If you were to reverse it, wouldn't the ratio from 3 to 1 be like the inverse of that?
From 3 to 1?
Yeah, why would you not like reverse?
Well, 3 to 1 it's not the doubling of experience. But we did reverse it here. You know, like the one on top is the shorter, the one on bottom is the longer time. So shorter time up top in the numerator and longer time in the denominator. So this is like when we went from the second to the fourth. So 0.91 is the ratio of the second. The second one took us 24 minutes, and the fourth one was 21. So what I'm saying is we can back extrapolate to the first time, because it's going to take, the second time is 91% of how long it took the first time.
14 minutes.
14.1 minutes is Z sub U, yes.
Yeah.
So if U is 100, then Z sub U is 26.38 minutes times 100 to the power of negative 0.1361. So this factor will be 0.5343. And so in the end, Z sub U is 14.09 minutes. So if you could do the same thing by looking at the ratio of the 8th time to the 4th time. So 19.87, if I'll just get out my calculator here, 19.87 divided by 21.84, it's 0.91. Same thing from the 3rd to the 6th. If you've got 20.67 divided by 22.91, 0.91. So double the experience, it only takes 91% as much time once you've doubled your experience. So, all right. Are there any remaining questions on this example problem?
I have one.
By 100 to the power of, yes, that's right. 14.09, yep. All right, so if we just revisit the announcements here before we go our separate ways, remember that you've got an assignment that's due on Thursday. Thursday by 4 o'clock is when that homework 9 is due, and then we just look at the schedule real quick. So homework 9, the homework you're turning in on Thursday is your last homework assignment of the semester. And then the project, which is due next week. I guess next week's the last week of classes, right? Boy, it went quick. It went quick. And then our final is on Tuesday, the 25th of April. And for the final, the exam is comprehensive, and you can bring your formula sheet to help with that. You can bring 3 pages of notes, you know, so that if you wanted to bring the same formula sheet that you created for exam 1 and exam 2 plus 1 more, then you can do that for the final exam.
How many worked out problems can we expect for the final?
I don't know. Because we've got more time for the final than we have had for our midterm exams. You know, our midterm exams have been needed to fit into 75 minutes. So I think you should just expect it to scale accordingly, you know, like 120 minutes compared to 75 minutes. And so I don't want to paint myself into a corner by committing to a certain number of problems for the exam, but it'll probably be, you know, a little bit longer than the midterms have been. All right, well, that's it for tonight. I'll see you on